Let's talk about the internet. I mean, we use it every single second of every day. It connects literally billions of us. But what is it? Really, it feels like this magical, invisible cloud, right? Well, today, we're going to pull back the curtain and look at the actual wires, the light, the rules that make our entire digital world tick.
Think about it. It all starts with something you do 1,000 times a day without even thinking. A simple click. And in what feels like an instant, information from halfway across the planet just appears on your screen. How? How does that actually happen? Well, that's the journey we're going to take right now.
So here's how we're going to break it down. We're going to build this thing from the ground up. First, what even is the internet? Then we'll look at the physical stuff it's made of, the rules that keep it from being total chaos, what internet speed actually means, and then, at the very end, we'll put it all together and trace that single click from start to finish.
All right, first things first. Let's get this whole cloud idea out of our heads. The internet is not a cloud. It is a very, very real and very physical thing. When you boil it all down, this is it. That's the core definition. It's just a gigantic World Wide Web of computers, phones, servers, smart fridges, you name it, all connected and talking to each other. It's not one single entity, it's the connection between all those devices.
And here's the absolute key. For this massive, open, and kind of chaotic network to work at all, every single device, from a massive server to your phone, has to agree to play by the same set of rules. These rules are called protocols, and honestly, they are the unsung heroes of our digital world.
Okay, so if it's a physical network, what's it actually made of? Let's look at the hardware, the stuff you can actually touch that makes up the internet's backbone. It really all comes down to three main pieces of tech.
First up, the good old copper cable. This is basically a souped-up version of the telephone wires we've used for a century. It just sends data using simple pulses of electricity. You've definitely seen these. They're the Ethernet cables probably plugged into your computer or your Wi-Fi router right now. They're kind of the workhorses for our local networks at home or in the office.
But to go long distance and to go super fast, we need something way more powerful. And that's where fiber optics come in. These things are incredible. They don't use electricity, they use light. They shoot tiny pulses of light down impossibly thin strands of glass, and they can carry just enormous amounts of data. These are the cables that stretch across entire continents and, yes, lie on the bottom of the ocean, connecting the whole world. And just to give you an idea of the sheer scale we're talking about, a single one of these fiber optic cables can carry up to 26 terabits per second. Okay, that's 26 times trillion bits of data flying by every single second. It is a truly mind-boggling amount of information, all being carried on a beam of light.
And last but not least, we have wireless. This is the final leg of the journey, right? It's the magic that gets the internet from the plug in your wall to the phone in your hand. Your router just takes all that data coming in from the physical cables and blasts it out as simple radio waves. But, and this is super important, your Wi-Fi is really just a short-range bridge back to that physical wired network.
So when you lay it all out like this, you can see why we actually need all three of these technologies to work together. Wireless is awesome and convenient, but it's got a pretty short range. Copper is super reliable for connecting things in one building. And fiber? Well, fiber is the absolute king of speed and distance, but it's pretty expensive to install. Each one has a very specific job to do in getting data from a server somewhere out there, all the way to you. Okay, so we've built the physical roads, the copper wires, the fiber optic highways, the radio waves. But how does the data, the information itself, know where it's going? That brings us to the next layer, the invisible rules that basically act as the internet's traffic control system.
Honestly, the best analogy for protocols is just that. They are the rules of the road for data. They tell every packet of information how to be addressed, how to avoid traffic jams, and how to make sure that the thing you send is exactly the thing that gets received, with zero errors.
Now, you don't have to be an expert here, but it helps to know the big three. First, you've got IP, the Internet Protocol. Think of this like a unique mailing address for every single device on the network. Then there's TCP. TCP is like the Postal Service's tracking and insurance. It breaks your data into little pieces called packets, makes sure they all arrive safely, and puts them back together in the right order. And finally, you've got HTTP. That's simply the language your web browser speaks to ask a server for a website. All right, we have the physical hardware, we have the rules of the road. Now let's talk about the thing we all care about, speed. We all say we want fast internet, but what does that word even mean? Turns out, it's really a mix of two totally different things.
This is by far the best way to understand it. Bandwidth is how wide your internet highway is. How many lanes does it have? How much data can travel at the exact same time? Latency, on the other hand, is how fast a single car can get from point A to point B. It's the travel time. And for your internet to feel fast, you need a good combination of both. And you've definitely seen this before, right? When you run one of those internet speed tests? Well, you're literally measuring these two concepts. That ping number, that's your latency, and it's measured in milliseconds. And those big download and upload numbers, that's your bandwidth. That's the width of your highway, measured in megabits per second.
And hey, have you ever noticed your download speed is always way higher than your upload speed? Well, that's not a mistake. It's totally by design. Because think about it. Most of us spend our time consuming data, streaming movies, loading websites, listening to music, not sending huge files out. So the internet providers give us a much bigger highway for all the traffic that's coming to us.
Okay, we have officially assembled all the pieces of the puzzle. We have the physical foundation, the rules of the road, and we know what speed really is. So now, let's put it all together and follow the incredible journey of that one single click we talked about at the very beginning.
So here's the entire trip, step by step. You click. Your computer sends a request out as radio waves to your router. That request then travels through local copper wires in your neighborhood. Then it hits the big time, zipping across the world as a beam of light in an undersea fiber optic cable. The whole time, IP and TCP are acting like it's GPS, making sure it gets to the right address. Once it finds the server it's looking for, the whole process just happens in reverse, and the website's data flies back to your screen. And all of that happens in the blink of an eye. It's just wild.
And that brings us right back to where we started. When you strip away all the complexity, that entire incredible mind-bending journey is really just one computer talking to another computer across a giant global network. It's not magic at all, it's just really clever engineering.
So from electricity and copper wires to light and glass cables, to the invisible rules that organize all the chaos, the internet is really just a system of layers, each one built on top of the last. And it kind of makes you wonder, what's next? What's the next layer going to be that changes everything all over again?